The immune system is made up of this complex network of cells and tissues and organs that all serve to protect the body from infections and from other diseases. So let's talk about how this system actually works and the breakpoints that can occur throughout, which would then contribute to one experiencing autoimmunity. The first thing that happens is an antigen makes its way into your system. An antigen is just a broad term that refers to something like a bacteria or a virus or really just some sort of pathogen or really anything foreign. Things like certain foods or chemicals or even your own tissue can become identified as foreign to your immune system. So what happens next? An antigen presenting cell will then bind to that antigen. Think about it kind of like a security guard that's just surveying the area. And once they encounter an antigen, they engulf it, kind of like putting someone in handcuffs and then just putting them off to the side. Once they engulf that antigen, they then have to decide, do I want to trigger an immune response to this antigen or not? So you've handcuffed this person, you've set them to the side, but do you really want to call the police and get them involved, or would just a stern talking to suffice and then send them on their way? If these antigen presenting cells decide that they would like to trigger an immune response, they then have to release a signal, kind of like a security guard calling in for backup. So who do they call? They call in specialized cells called T helper cells. Think about T helper cells kind of like the 911 dispatch. The 911 dispatch will then call the officers and say, hey, I need you to go to this area. They give the officers the coordinates and they're on their way. The officers are what we call natural killer cells and cytotoxic T cells. These natural killer cells and the cytotoxic T cells are kind of like the soldiers of the immune system. They're the actual boots on the ground. Their job is to go and destroy that antigen. But there's a problem. These soldiers are fighting this fight in the dark, meaning it's hard for them to see what they're shooting at, which, as you can imagine, can become problematic. If you can't see your enemy, how on earth are you supposed to destroy them? So how do they solve this issue? Well, the T helper cells, aka that 911 dispatch, gets word that they can't see their enemy, so these T helper cells call the B cells, and B cells produce antibodies that will tag the antigen. Once that antigen is actually tagged, it makes it much easier for the soldiers or natural killer cells and cytotoxic T cells to go and destroy the enemy or antigen. So just to keep this example that we've been using, think about it like this. The 911 dispatch calls some distributor who will then supply the soldiers with night vision goggles. And now they can actually see their enemy and make sure that whatever they're killing is the enemy troops. Then once the entire antigen has been taken care of and destroyed, it's the job of the T suppressor cells, kind of similar to the supervisor, to say, all right, our work here is done, let's pack it in. But if these T suppressor cells don't work for whatever reason, now these soldiers just keep on destroying tissue, and this is one of the mechanisms behind autoimmunity. These soldiers aren't the brightest, so they will keep on killing until they're told to stop. Without the supervisor saying enough is enough, these soldiers will run rogue and continue killing more and more tissue. Then lastly, we have what are called the regulatory T cells, or the Treg cells. And they're kind of like the supervisor to the supervisor. Their job is to regulate everybody and make sure that the T helper cells, aka that 911 dispatch, is not calling in more troops, and also make sure that the T suppressor cells are calling it quits at the appropriate time. This is also one of the mechanisms that could lead to autoimmunity. So where are all the breakpoints? Well, if we start from the top, if the soldiers or natural killer cells and cytotoxic T cells are destroying everything, you can develop autoimmunity. If the T suppressor cells never shut everything down and say enough is enough, you can develop autoimmunity. And if your regulatory T cells don't have the appropriate distribution between calling in more troops and saying we're done here, then you can develop autoimmunity. If you're struggling with autoimmunity, I've created a free guide that you can download on our website that will walk you through the step-by-step process of how I personally progress through working with a patient who is struggling with autoimmunity. I'll leave the link for you down below.